The purpose of this video is just to summarize how to solve this fraction mechanics problem, of which we discussed the problem statement in the previous video. Now, if we look at question 1 and we look at the answer, the first thing is that we need to calculate is the critical crack size. Now, you can go and check in your notes. The beta value for an infinitely wide plate is almost equal to 1 in this equation, in the universal fraction mechanics equation. So the way in which we calculate the critical crack size, because remember we need to know up to what size the crack may propagate. And to calculate it, we calculate the stress intensity factor K1, which is equal to the nominal stress times the beta value, the crack geometric stress concentration factor, times square root PA, and remember the actual crack size is 2A. Then what we do is we say this is equal to K1C, the plane strain fracture toughness of the material. Now, we solve this A, the growth in this A, and we see that this A, they solve the crack size A, and that's 1 over pi K1C squared. We manipulate the equation, and we get for a beta equal to 1, 10 millimeter. Now, we want to model the crack growth per block. Now, unfortunately, you have to solve this numerically. Now, in Excel and all these programs, it's very easy to solve. So, what you do is the crack growth rate is given by the Paris rule. So, it's dA dN, which is C delta K to the power M. But very important, this delta K is only the positive stresses, the crack opening stresses, not the compressive stresses, because they don't propagate the crack. We manipulate the equation to say dA is equal to C delta K dN, and that's still true. We just separated this. And then we take it to a numeric equation. Delta A is C delta Km times delta N. Now remember, I told you in the previous slide that we are going to assume that the crack growth is so small that the change in delta K as a function of crack size, because we know delta K is equal to delta sigma. Delta sigma don't change because it's nominal stress times pi A. But for one block, we are going to assume that this delta K for the same delta sigma stays constant. That means beta square root pi A don't change for every block. That's just to simplify the calculations. Now, how do we solve it? We say, right, we have one block consists of a delta K, which is 280 times 1 times square root pi A. We have the initial crack size. It's 2A equal to 1 millimeter, so A is 0.05 millimeter. Then we say, right, so 0.05, and it can grow up to 10 millimeter. That's what we calculated here. It can grow up to 10 millimeter for A. And remember, on both sides of the crack, it will propagate at approximately the same rate. So we take this 280 times beta times square root pi A. There you can see the function coming into action. And then we say dN is equal to 2. And that means we calculate delta N is equal to 2. Then we do the same for 140. Delta N is equal to 30. Then we do the same for 70 times beta square root pi. And delta dN or delta N is equal to 30. And that will give us the crack growth C delta Km. We have it for all of them. The one is 2, the one is 30, the other one is 30. We calculate delta K for the specific crack size, and then we see how much the crack will grow. We take this delta A, add it to the initial A that we had, which was in this case it was 0.5 millimeter. So we add this delta A, and then we know what the crack size is after one block. And we repeat this process until we reach a crack size of A equal to the critical crack size 10 millimeter. And that's the process. You can program it in MATLAB or you can program it in Excel if you wish. But note, if you program it in Excel, it will take a tremendous number of lines. So to reduce that, you can assume, and I'm totally happy with that the factor beta times square root pi A stays constant for, let's say, 1,000 blocks or 100 blocks. Just make your assumption that works well for you, and I will mark accordingly. The important thing here for me is that you just understand how to implement this to solve the problem. I hope this helps. After the assignments have been submitted, I will give a full video that explains the whole process in detail.